there will be a quiz due on Monday. That quiz consists of 3 questions. The first 2 questions you can do already. I think the first question you can do with the material yesterday, and the second question you can do with the material I teach you today. And the last question should be doable using the material I teach you tomorrow. That's why I make it due on Monday. Okay, but if you want to watch the lecture video from WLAC, East LA College, for your 6.1, then you may be able to do that that problem earlier. Okay, somebody asked me if can get correct answers for quiz 2. Give me a second. Okay, I usually post the solution for quiz. I hope you're at the screen of my browser now. Okay, yeah. You go to the quiz. I post the solution there. I post the solution here. Yeah, okay, so for those who ask me that question, Thomas, can I get the solutions? Usually like couple days after you turn in your quiz. Basically, once I start grading it, right? Once I start grading it, then I'll post the solution there. Okay. Yeah. Yeah. Likewise for your test later on. I think I will start grading your test this Friday or Saturday. I will see. It is possible that I start grading it tomorrow. But yeah, I will post the solution also there. I will show you. Yeah, I will post the solution on the top here. Okay. Next time, will it be possible to get the quiz back before a test? Now that happens to be that test, that quiz happens to be, the material happens to be like a couple days before the test. Of course, I need to give you a couple days also to do the quiz. My purpose was like making that quiz as a, to make you start studying earlier. That's my purpose actually. Yeah, but for my old test, to study for your test, you still can study from my old test. Okay. Now, if you notice those questions in my quiz, actually, similar problems you see in my old test. You know, very similar, very similar. So I hope I answers one of our friends' question. Okay. Actually, I would like to go to something else right now. That reminds me. Something. Yeah, great. Yeah. Actually, I would like to mention something about your old tests. When you study from my old tests, right? Give me a second. When you study from my old tests, let's say, let me use this as an example. Let me use this as my example. Now, this is one of the tests I gave actually in spring. Yeah, this is in spring question. Now, do you see this thing, like this number, small numbers I put next to the question here? This is question number 9, and this question means 12 points. Okay, so when I give you these 12 points, for example, here, it actually means 2 things. First one, that question worth 12 points. Second, for you to do that problem, it should take you 12 minutes. It should take you 12 minutes. Okay, 10, so, well, to be more precise, 11 minutes. Okay, but since you are online, I give you 12 minutes for that. You have more than enough time, don't worry. Now, so when you practice at home, on how to do this problem, make sure that you finish this question in less than 12 minutes. Okay, that's how you measure your time. Okay, yeah, that's how you measure your time. Now, let me go back to, so when you practice for your tests in future, not only practice how to get it right, but also practice your time. Okay, also practice your time. One student asked me this question, I have not responded to her. Thomas, I bombed this test. I didn't have a chance to finish the last page of the test because I spent too much, must be because I spent too much time on the first 3 pages of the test. Now, then it must be because you didn't practice on the time management thingy. Okay, so you need to practice your time also, and the number of points for that question tells you how much time you need for that question. Okay, yeah, I make it in a way that we have some problems that is takes a very short time to do. Like the question in your test, the question of find the range, it doesn't take any 15 seconds. No, you should know what to do right away. Okay, you should not spend some time just to find out what range mean. Okay, some problems is longer, I know, and that's why I give you more points for that. Okay, some problems actually very short, but it's more on the hard side, so it takes you some time to actually think how to approach the problem. Now then that will be, I give you more points also there. Okay, that's for the test though. For the quiz, the points only how much that question worth. It doesn't really imply a lot of time. So you can say like for your quiz, take home quiz, right? In this case, if I give you 3 points, for example, then you can give yourself like around 3 or 4 minutes to do that problem. Okay. Yeah. I hope that explains. I will post this this quiz that will be due on Monday, maybe in the afternoon. But again, you can watch the lecture video related to that. Let me show you where to see. Remember yesterday I shared with you on the pages, right? So today I will finish up 5.5 and 5.6. And then tomorrow I will do 6.1, 6.2, maybe with 6.3. I don't think so. Maybe 6.1, 6.2. Yeah, but if you want to be ahead, you will watch the lecture video for this 6.1. I click on this page here. And then you click on this YouTube video. Okay, that was my lecture from last semester. Okay, let's continue with the lesson. I will continue with our 5.5b, the second part. Oh, by the way, that's now I remember what I want to say. Some of you actually have a chance to do the quiz and the test by writing on the pad right away. Now you may wonder how I actually write on this video here. How do you want us to write answer that requires scientific notation? Actually, no, you don't need that. Scientific notation is something you get from your calculator. But when you write on your test, I still need to write the decimal. Okay, scientific notation, unfortunately, is not the notation acceptable for probability. Okay, I understand. The scientific notation is acceptable in science, like if you have physics or in chemistry. Okay, now please mind you that when I did my PhD, I need to do some physics. So it's not that I don't know physics. My background in probability and statistics has something to do with quantum processing. How to say that? Basically, I need to learn some physics. So it's not that I don't know physics, okay? Mine is an intersection between physics, material science, and math, and in probability. Okay, but in probability, scientific notation, at least at your level, scientific notation is not an acceptable final answer. Okay. Okay. If you have greater than 5 zeros, if you have more than 5 zeros, you write maybe like 6 or 7 zeros. You write 6 or 7 decimal places first, and then you round it to 5 decimal places. So, for example, one of the answer we have was in our quiz was like 0.0000006 zeros and then 396 maybe. I don't remember precisely. So let's say we have this decimal. So you write this first, and then you round it to 5 decimal places. Okay, and when you round it to 5 decimal places, it looks like 0. Okay, yeah. When we round it to 5 decimal places, it looks like 0, but it is not 0. That's why I still write it this way. Okay, so that's why I still write it this way. Is it what you see? Yeah. Okay. Now I want to show you what I did here, just in case that if you have some money and you are willing to invest in this writing pad. This is my writing pad. Let me show you. This is my writing pad. So I use a laptop. Okay, I use the laptop. It's not because I don't have a desktop. I have desktop for my work, but I use laptop because this laptop has the webcam at the same time. Okay, now so if you already have laptop and you have webcam, but you don't have any way to actually write into the file, right? Like some of you, I say that in case you have X Pen, this is what we call, I call X Pen. So I have a pad here, okay, with a pen. So I can write into the file without printing it out. So instead of printing it out, if you don't want to buy printer, if I were you and you have a choice buying printer or this pad here, writing pad here, buy printer. Printer is actually more important. Okay, but if you already have printer and you wonder what I did, then I use this. Let me share with you. I feel like I'm now a seller. No, I'm not. I'm not trying to sell you anything. So if you go to Amazon.com, just to show you the product, not to tell you to buy from here, just to show you the product. So I wonder if that's what you see. That's what you see. This is what I use. Okay, I use XP pen. Yeah, this is what I use. Not this one. I use this one. I use this one. 6. No. This is too small. No. Not that one. Not that one. Okay. I use this one here. This is the one I use. Okay. In case you are interested, like, oh, you know what? Because you may be able to do it faster though if you without printing it out, and it's actually look nicer, and you can erase, as you can see, right? You can erase, and then how do I actually write into the file? Like, how do I actually write into your file? For example, when you send me the PDF, okay, when you send me the PDF, when you send me the PDF, this is what I do. For example, this is what I did. So I insert the file. Let's say I insert this file. That's the file here. Okay, and then I write onto it. Solution. And if I write something wrong, of course I can erase it using my XP Pen. Okay, so I use XP Pen together with OneNote from Microsoft. Okay, there are other software which is better though, but I think those softwares either hard to find or you need to buy. And I'm a cheap guy. I try to make it cheap for my students. Okay, I guess I get too much into those things. Those are technicality, but I teach you this so that in case you need that for your other class, because I assume I have to say this. It seems like this online class will be the remote learning very likely becomes a new normal, such that you can say that out of, let's say, 5 classes you will take in one particular semester, let's say next year, once this pandemic already fades out and we can go back to school, trust me, there will be more classes that you need to take online instead of on campus. Okay, so let's say out of 5 classes you have, either 3 or 2 of them will be online. Now, once 3 or 2 of them will be online, there's a big chance you will need, for example, printer, and you will need this writing pad. Okay, yeah, of course, if you have already have a iPad, for example, then you don't need to have this writing pad anymore. It's just something I think you need to invest into though, and consider that part of your education. Okay, yeah, so we will spend less in textbook and more in infrastructure. Okay, I try my best to get you something to get you something cheap, like your, for example, your textbook, right? For example, your textbook, I already give you the file. Okay, but at the same time, it's not something your teacher can help you with all the time. Okay. Well, anyway, 5.5b, it's on part C, permutation. I'm sorry, combination. It is common when I teach these counting techniques, I separate permutation and combination into 2 different days. Why? Because combination, permutation are very, very similar. Very similar to permutation, to the point that it may be confusing. Okay, to the point that it may be confusing. Like combination and permutation not only have a very similar Shen name, like the last 4 letters are the same. Actually, the last 5 letters are the same. Okay, and the starting point, the condition are actually the same. The situation are the same. Okay, so for example, the situation for combination is actually the same with permutation. That is that you have one box with an distinct item. And distinct items. Now, the action is different. The action is different. Let's select R items. Order is not important. Now, that's why, because the order is not important, you can select these R items at once without taking it one by one like in permutation. Permutation, order is important. That's why when you select these R items, you need to do it one by one. Let's say, for example, here, let's say I have example 1, I have a set of 5 letters A, B, C, D, E, and we want to select two letters from there, regardless the order. Okay, now because it is regardless the order, you can just grab two at once without looking at them. Okay, instead of doing it one by one. Okay, of course you still can do it one by one. Okay, you still can do it one by one, but we will disregard the order. Okay, let's say we select two letters, and then part C, the question, how many possible, maybe I should say, how many combinations possible? Or besides using the word combinations, how many groups possible? How many sets possible? Basically, the words being used here implies that the ordering does not matter. Okay, the ordering does not matter. So, like in this case, how many sets of two-letter are possible? And the answer is, the solution is N combination R. I usually read it N choose R, N combination R. Now in this case, we have 5 letters, and I need to select 2. Then there will be 5 combination 2 sets possible. Now, when you use your calculator, or if you remember how to compute that, that is 5 times 4 over 2 times 1. That's 10 sets. Now, of course, you should wonder, Thomas, what are these 10 sets? What are these 10 sets? Now, let's go to this then, from this set of A, B, C, D, E here. Now, when I select 2 elements from there, so is the difference between permutation and combination dependent on if the question cares about order or not? Yes, exactly. The only difference between permutation and combination is permutation care about the order. Combination does not care about the order. How did I get the 4? Which 4? Oh, this guy here. Take a look on my lecture yesterday. How did I compute manually by hand 5 combination 2? So start from 5, 2 factors, and 2 factorial at the bottom. Okay, or you can use your calculator, of course. Okay, now what are these 10s? Now let's select 2 elements from these sets of 5 letters. And what are those 10? First one is AB, second AC, AD, AE. And then BA, oops, BA has the same elements with AB. Only the order is different, right? But if the order is different, it's fine. We don't want to double count it. Okay, that's what it means. Okay, so BA has the same element with AB, so I don't count BA anymore. Okay, and then BC, BD, BE, and then CA, which already counted at AC, right here. Okay. CB, which already counted at BC, so I don't count it anymore, right? Okay, and then CD, CE, DA, already counted at AD. DB already counted at BD. DC already counted at CD and DE. Finally, EA already counted, EB already counted at BE, EC already counted at CE, ED already counted at DE. So if the order is important, if order is important, there will be 5P2, which is 20 permutations. And this is the 20 that we have in this list here now. But if the order is not important, then we cancel this guy, we cancel this. Now notice that then I only have 10 left. This is the 10 we are talking about. Will permutation always be greater than combination? Almost always, I can say yes. In a very rare case, they're equal, but never less than. The number of permutation can never be less than combination. Okay, but maybe equal. In very rare case, okay? In fact, if you choose only one, right? If you select only one, then permutation combination will be the same. Okay, now, so the 10 that we talk about here, the 10 sets that we are talking about here, is the one we count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, those are the 10. Okay, those are the 10. Now, while permutation is quite easy to understand, like what I said here yesterday, combination, however, is actually on the harder side. Is hard. At least hard to understand at first, okay? The work is actually short. It's more about when you see a case, can you identify that right away that you need to use combination, okay? And the problem with counting techniques, including especially this combination, is that we may apply this to zillions of cases. Let's say today I give you 100 examples. Tomorrow I can come up with another 100 examples that have nothing to do with the first 100 I show you. Okay. In other words, the argument that Thomas, you never give this kind of problem is actually missed the point, because I can always find different problems. I can always find different problems that's not related to my previous examples. yet the underlying idea is exactly the same. Let me put it this way. If in spring 2020, I give 20 examples on combinations, then in summer 20, this intersection, I can come up with 50 other examples that I have never done before in my previous slides and I'm in my previous time. So do not expect that you will see similar questions. However, the underlying concept will be exactly the same. Now, let me show you this example here. So we already have example one. We have letters A, B, C, D, E, and we want to select 2 letters regardless the order. How many sets of 2 letters are possible? And we compute it. There are 10, right? That's our example one. Now let me show you example two. There are 5 points on a circle. There are actually infinitely many points on the circle though. But suppose we have 5 points on the circle. Suppose we have 5 points on the circle. And it doesn't have to be a circle actually. I can make it ellipse. Yeah. So let's choose 5 points on the circle. 1, 2, 3, 4, 5. Okay. And then each segment maybe I should say a segment or a chord to be more precise. Let me use the formal word, a chord. The chord can be drawn by connecting two points on any 2 points on that circle. In other words, then I have 1 chord here. This is 1 chord, right? Okay, let me use different color. This is 1 chord. Okay, this is another 1 chord. Okay, that's another 1 chord. Oops. Okay. Now the question is how many chords can be drawn using these 5 points. Now, of course, you say, Thomas, I don't need to learn anything new. I can just draw lines. Okay, just draw it then. So far we have 4 and then 5. Is that all? No, we can draw more. We can have 6, 7, 8, 9, 10. Now, what we still have this issue though, is this all? You can keep on drawing it and then lose track, right? You're lucky it's only 5 points. What if I make it 50 points? Then you need to spend more time in drawing it, right? No, that's not the direction we want to go to. Now, as you can see here, yes, we still have 10 chords. We have 10 chords. But why our answer 10 chords here is the same to the answer you have in example 1? Well, because of the following. Every chord takes 2 different points. Right? So the number of chords possible is the same to the number of different 2-point sets. And notice every time you draw a chord, it doesn't matter where you draw it from. Okay, you draw from here going here is the same to if you draw the chord from here going there, right? Okay, so the order doesn't matter. The order doesn't matter as long as it takes the 2 same points, it will give you the same chord. You see what I mean? Okay, so in this case, the order doesn't matter. Okay, and every chord takes 2 different points. So the number of chords will be equal to the number of different 2-point sets. Now, with that said then, how many chords we can create, how many different 2-point set we can create? That will be 5. From 5 points, do combination 2, or 5 choose 2. Then you will get 10 number of 10 different chords. So you see, I hope you see that the questions A, B, C, D, E, in part A, you select 2 letters of 2 letters, how many sets possible? Even though the question seems very, very different from this example 2, the underlying concept are exactly the same. The question was not what are those 10 chords. The question was not what are those chords. The question just how many. Okay, the question just how many. Now, of course, somebody may say, Thomas, I can just draw it one by one, right? Yeah, okay, fine. If I make it 50 points, then you start thinking hard. Well, Thomas, when you use large number, of course, it's confusing. Okay, then don't use large numbers. Use the same 5 points. And my question to you, how many triangles can you draw? Good luck if you want to count it. Okay, so example 2 star. How many triangles can be drawn with 5 points on a circle? And suppose you dare enough challenging me, Thomas, I will just draw it. Okay, fine. Go ahead, do it. So select 5 points on a circle. Okay, and then draw the triangle. And I will use different color. 1. This is 1 triangle. That's 1 triangle. Okay, and then another one, let me use another color. Let's say this triangle here. Ooh. You start getting overwhelmed. You still have too many points to deal with. So drawing it, even if you have in your pocket a lot of different markers, different colors, still doesn't help. It still doesn't help because that's not how you're supposed to approach the problem. Okay, so I usually get this comment from students. Thomas, I studied so hard for this class. And I just get a C, I get disappointed. Now, the thing is, no, that's not how you should approach it. Okay. Of course, you need to study hard, okay? But if you go to a wrong direction, you won't arrive, okay? You need to study smart. Make sure you go to the right direction first, okay? Your method should be right, then hard. You cannot study stats by reading biology book, put it that way, okay? Yeah. No, I'm not that I say biology is not important. That's one field that I would like to study more. But I don't expect to learn statistics from biology textbook. Okay, it just doesn't make sense by in that one sentence. Okay, so how do we answer this question faster then? Well, every triangle takes 3 points, so the number of triangles you can draw must be 5. Choose 3, and if you use your calculator, it will be 10 also. Okay, so this type of question, if I ask you, I will give you 3 minutes. Why? It takes you 2.5 minutes to think how to approach that, but then only 30 seconds to write the answer. Now, in other words, to come up with this is hard. Once you know, oh, it's 5 choose 3. Yeah, I know it's 10, but how do you get that 5 choose 3 times? Well, 5 points. How many 3 choices? How many choices of 3 items you can do? Okay, now that's for this example 2 here. Let's do example 3. Example 3. 5 friends shaking each other's hand. How many handshakes possible? How many handshakes happen? The answer will be 5 choose 2 also. Because 5 people, every time they do handshake, every handshake takes 2 different people. Okay, every handshake takes 2 different people. So the number of handshaking happen is equal to the number of 2 different people that you can make. Okay, so if I draw the diagram, you have 5 people, Mr. A, B, C, D, E, they shake each other's hand, right? Do you notice that suddenly the picture looks like what we have in example 2? Okay, which comes from A, B, C, D, E, which is in our example 1. So notice that a set of 2 letters in example 1 develop into the number of pores we can create in example 2. Now example 3 is about handshaking. Okay. Now, in the last 3 examples, how would you know we to use combination over permutation? Since the question does not state whether order matters or not, from the implication. So what makes this combination hard is you need to be able to read between the lines Okay, is the order important or not? When I shake your hand, does it mean you shake my hand too? Okay, no. You cannot say, oh, Thomas, you are the one shaking my hand. I didn't shake your hand. No, that's BS, right? We know that's not true. Okay, right? When we draw a chord in example 2, then it doesn't matter how we draw it from point A to point B or point B to point A. Either way, you get the same chord, right? Okay, so likewise, handshaking also the same. Uh, uh, my wife, for example, my wife cannot tell me, Thomas, you are the one marrying me. I didn't marry you. Right? Okay. So why? So from here we see that even though it doesn't say explicitly the order matters or not, we know that handshakes requires two people in this case, but who shakes whose hand doesn't matter. In the end, these two people do handshake. Okay. Yeah. When we fight, when we, let's say we have argument, right? When we have argument, for example, nobody can say I'm the one arguing with you and you are not arguing with me. No, if that's the case, you can say I'm yelling at you, okay? But when we say argument, it's like two sides actually argue, okay? Now argument doesn't have to be a bad thing though, okay? We need to develop our argument skill, of course, in a nice way. That's what we need to develop. But yes, implicitly, that's what makes combination harder, because you need to be able to read between the lines from the words being used. Oh, is this is order important, or this one order is not important, like that. Okay, yeah. So you ask a very important question. You need to know. Yeah, you need to know from the question if the order is important or not. Okay. Mm-hmm. Of course, your interpretation will also say something about your answer, but you need to interpret that from the question. Okay. So this is 10. Also, we know 5 choose 2 is 10. So 10 handshakes. So this is example 3. Is it example 3? Yeah, okay, that's example 3. Example 4, I can give you more. Example 4, 5 teams play each other once. How many games should be played? Should be played. Then you will say, oh, 5 teams. Okay, it takes 2 teams to play a game. So there will be 10 games. Is it okay? No. I guess I will need to stop with the examples. Okay. Giving you too many examples may be confusing. Okay. So I'm the type of instructor who don't give too many examples, no. But from each example, I try to go over that example fast. So when you study from me, okay, don't just look at that, oh, this is example 1, the answer is what? Example 2 is this, and this is how I do it. No, 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 no. Pay attention to the explanation. Because if you don't pay attention to the explanation, you cannot argue, you cannot reason how to get the solutions. I can give you 2,000 examples and you still don't know how to answer the 2001st question. No, no, okay? And I actually learned it from my professors at USC. She said, Thomas, I was her TA, and she said, Thomas, instead of giving so many examples and students get overwhelmed with so many examples, how about you give just a little examples, but explain each example very, very well, so that students can do their own problems in future. The purpose is we are not exposing them with too much examples and get confused, but we give them the tool to handle all those problems. And I basically follow that philosophy. Now, this professor is a lady named Florence Lin. She has PhD in math. I forgot which university, one of the Ivy School, and PhD in physics from Harvard, and MBA from USC. And she works on something called three-body motion. That's one of her research, three-body motion. It's a very difficult issue though. Don't ask me about that. I don't know anything about it. Now, three-body motion has something to do with this. I'll give you an illustration. What's the issue? Okay, you know the Earth and the Sun. The Earth and the Sun. Now, how the Earth goes around the Sun, we actually know that pretty well. The problem is once you put a moon rotating around the Earth, while the Earth rotating around the Sun, then we will start having issues with the computations that, for example, what happened with gravity. Okay, when the Sun is there and the Earth here and the Moon is here, for example, right? What happened to the gravity on Earth? Now, what happened to the gravity on Earth if the Moon is actually on the other side? What happened to the gravities here? Okay, now that makes the path of this moon is not perfectly circle, just like the Earth goes around the Sun, not circle. It's actually an ellipse shape. You know, so because of that, then we have summer. That's when we are closest to the Sun, and when we have winter, we're actually furthest from the Sun. Okay. Otherwise, if we live in the the Earth goes around the Sun on a perfect circle, then we pretty much have no issue with the weather. Like the weather will be hot, hot in the equator for the whole year, and it will be cold in the poles for the whole year. You know. And trust me, you don't want that kind of uniformity. So we do need some change in our weather though. Okay, now I'm not talking about climate. Okay, I'm talking about weather. Okay, you expect that we don't want to get cold. I mean, imagine your life without any variation, without any season, right? That's so boring, right? Okay. Yeah, thank God for that though. Okay, these are all the combination problems. Examples. Now let's do some problems from our textbook. I will pick problems from our textbook. Let's take a break first. We will come back at, right now it's 8:58. Let's come back at 9:08. Okay. These are the problems I get from our textbook from section 5.5. Okay, we will apply what we learned so far. Number 48, 4 members from a 50-person committee are to be selected randomly to serve as a chairperson, vice chairperson, secretary, and treasurer. So they will select 4 people to sit at these different positions. Now then, because they tell us the position, these 4 people in different positions, then the order is important. Okay, the order is important. Now, let's say Thomas being a chairperson and Thomas being a treasurer are two different positions, right? Okay, honestly, you will prefer me to be a secretary instead of treasurer. Why? Because I gamble, right? If you let me hold the money, I may gamble it away. Okay, while as a secretary, I think I'm really good at keeping details. Okay, yeah, because of they tell us from these 50 people, they will select 4 members for different positions. Then the order is important. In fact, we can actually do it using the first method, counting principle. Method number 1, you do it this way. The first position, chairperson, there are 50 people. For each choice you made there, you have 49 people for vice chairperson. You have 48 people to select from for secretary and 47 people to select from for treasurer. Or the second way to look at that, you have 50 people. How many ways can you permute 4 of them? 50 permutes 4. You have 50 people from a box. You choose 4 of them one by one in order, right? So you see it suddenly becomes a permutation problem. Now suppose they don't, the question did not tell us about this position. Position. So let's say, well, 4 members are to be selected from 50 people to form a committee. Then how many committees are possible? Then the order is not important. I think I should say then there were no ordering. It's conditional, right? Conditional sentence. There were no ordering. And therefore, there will be 50 choose 4 committees. Here, 50 permutes 4 leaderships. Okay, because the order is important. Okay, now number 52. How many different simple random samples of size 7 can be obtained from the population whose size is 100? So you have 100 elements. You have 100 elements. You need to select 7 from there. You need to select 7. 1, 2, 3, 4, 5, 6, 7, let's say. Okay, now how many selection of size 7 can be done? How many? Did I record this already? How many selection of size 7 possible? Then the order does not matter, right? Because you just need to choose 7 of them. Doesn't matter which one comes first, as long as you get 7 at the end. There will be 100, choose 7. Then from there you use your calculator. 100, choose 7. I get, ooh, that's a very big number. That's 1.60075608 times 10 to the 10. Now then I move the decimal point 10 times 16007568 10. Okay. You will see because it's to the power of 10 here, 10 to the 10. So this one will be at the 10th place. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm sorry, it has 10 digits after that one. Yeah, just like this. Like when I have 1.2 times 10 to the 2, this is actually 1.2 times 100, right? So 120. Now notice that there are 2 digits after the first one. There are 2 digits after the first one, like that. Okay, so when you have this 1 point something 10 to the 10 positive exponent, then there will be 10 digits after that first number. Okay, I saw somebody put me a note there. 16 billion something. Yes, that's right. 16 billion something. Okay, it's slightly more than, no, I should not say slightly more. It's 16 billion and 7 billion something. Yeah, it's a larger than that. For this kind of answer, do you want us to write all the digits or only 5 after decimal? No, you need to write all the digits because this is all integers though. Yeah, if you want to include the decimals, it will be 5 decimal places like this. That's 5 decimal places. Okay, but this is all integers. This is all integers, not the decimal part. This is not the decimal part. So unfortunately, yes, you need to write all of them. Okay, yeah, you need to write all of them. So no rounding for this answer. No rounding. Well, because we rounded to 5 decimal places, right? Not 5 integers. We don't round it to the thousands or the million like that. No, we round it to 5 decimal places. So we only round it if we have decimals. Like we have numbers after the decimal point. We don't round anything before the decimal point. See, we have integer part. Oh, sorry. We have integer part and then decimal part. Let's say 34.567, right? Now this is the integer part. This is integer part. This is decimal part after the decimal point. Okay, now then we do not round on the left hand side. We only round the decimal parts up to 5 decimal places. Okay, for the integer part, don't round. Okay, for integer part, don't round. Okay, especially later on when we get into probability, such little rounding may have a big effect though. It's quite sensitive later on. Okay. Now, number 54, you see that it gets faster, right? It gets faster because once you get the understanding, then it will be a lot easier. Now, a family has 8 children, and this family has exactly 3 boys. How many different birth and gender orders are possible? It seems like order is important, huh? Okay, but let me show you how we can approach this problem. Okay, how we can approach this problem. Let's do it this way. The idea is like we have boy or girls, right? Boy or girls. Okay, so you have 8 children. So 8 children, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now you need to have 4 boys. If 4 of them boys, how many girls? 5 girls, right? If, I'm sorry, 3 boys. If we have 3 boys, then 5 of them will be girls. Is it right? Okay. Now, you can start deciding which of these 8 here to be boys. For example, this is one choice, right? This is one choice. You can name it ABC. Yeah, you can name it the first child is co A, the second child is co B, the third child is co C, co D, co E. So that's how we know that Kobe Bryant is the second child. Is it right? No, I'm kidding. By the way, the correct pronunciation is supposed to be Kobe Bryant, not Kobe Bryant. It's supposed to be Kobe. If you ask his parents, his name Kobe actually coming from the city in Japan. Now, don't ask me why they chose that. Okay, but that's the parents' right? And for that reason, his name's supposed to be pronounced Kobe instead of Kobe. But to be honest with you, it's up to him though. If his parents say Kobe, but Kobe Bryant says, call me Kobe, then Kobe it is. Okay, then but once you know that his name is Kobe, then his older brother or sister must be Ko-A. Well, anyway, so you see that it's basically how to choose 3 of them to be boys, right? Okay, is the order important? Now, even though the question has something to do with the ordering, but the way you choose it actually doesn't matter which one you choose first. Okay, so that's the first choice. The second choice may be this guy, and then this guy, and then this guy. Okay, notice that even though I choose E first, and then B, and then G, even though I choose it in that order, in the end, the boys, if with that choice, will be the same to if I choose B first and then G and then E. It will be the same if I choose G first and then B and then E. Either way, this will be the boys, the rest are the girls. Okay, now that's one way to approach this problem, such that to answer this question, it will be 8 combination 3. Which I believe is 56 different ways. There will be 56 different birth and gender orders. Okay, you can make it though. B, 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 G, 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 G. That's one, right? Okay, and the other one B, B, G, B, G, 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 G. That's 2. B, B, G, G, B, G, G, G. And then you need to be patient enough to get all those 56. Now, without knowing how to compute it properly, you may write all those 56 and still wonder if you miss anything. So listing them is not a good approach because you don't know when to stop. Okay, so no, don't say, Thomas, can I just list all of them? Yeah, you can. Good luck. Right? Okay. Now, actually, from this same question number 54 here, for oh, when I say A, B, C, D, E, F, G, H here, it's the ordering. So this is the first child, the second child. Yeah, this is the first child, the second child, the third child, and so on and so forth. Not this. These are not the name. Well, you can call it the name, but I named them A, B, C, D, E. You know, of course, if I really decide to name my children A, B, C, D, E, F, G, alphabetical order, right? I will not start with B and then A and then G. You see what I mean? Yeah. Okay, so do you want to choose the first child to, in this case, if I use BEG, right? It means that my second, my fifth, and seventh child be the boys. Okay. Now, by the way, from this example number 54, I hope you also realize that we will get exactly the same answer if you have done 8, choose 5. Do you realize that? Instead of choosing 3 of them to be boys, that's the same to say you choose 5 of them to be girls, right? The same consequence. Does it make sense? Okay. That also explains earlier in our one of our example much earlier. Here. Do you notice that 5 combination 2 is 10, 5 combination 3 is also 10? Now, why can that happen? Well, as long as the number here add up to 8, in this case, 8, right? Then it will be the same. So for example, 8 combination 2 should be equals to 8 combination 6. Okay, because the 2 plus 6 give us this 8. Okay, another one, let's say 13 combination 5 will be equals to 13 combination 8. Why? Because 5 plus 8 give you 13. Okay, I hope I can give you a simpler illustration. Let's say that 6 choose 2, we know that will be equal to 6 choose 4. Now, what am I trying to say? So suppose you have 6 options. 1, 2, 3, 4, 5, 6. Okay, and we want to denote this either with A or B. Suppose the question is, how many ways can you put A's? The number of ways to put 2 A's correspond exactly to the number of ways you can put B's. Because if you choose 2 of them to be A's, it also means the other 4 needs to be B. Okay, so the number of ways you can put 2 A's will be the same to the number of ways you can put 2 B's. Okay, or maybe if I reword it, let's say I have 6 questions, right? Let's say I have 6 questions. The number of ways you can get 2 of them right is the same to say the number of ways you can get 4 of them wrong. That's just a consequence. Okay. Another way to say it, suppose I have 6 people. Now, of course, if 2 of them are boys, then 4 of them girls, right? Now, the number of ways you can have 2 boys will be the same to the number of ways you can get 4 girls. Okay, that explains a little bit about that phenomena. Oh, Thomas, why they come up to the same number? Well, it's possible because the logic behind it is the number of ways you choose 2 of them to be right is the same to the number of ways to choose 4 of them to be wrong. Okay, so the word order here, the word ordering here may be misleading as if the order is important, but if you think about it, like again, you can list that like the way I showed you earlier. Like let's say you have 8 children: the first, second, third, fourth, fifth, sixth, seven, 8. Let's say in every line you need to have 3 boys and the rest are girls. So how do you place 3 boys here? The number of ways you choose to be boys, let's say I choose this to be boys, and then this guy to be boys, and then that guy to be boys. In the end, I still have 3, 5, 8 to be the boys, regardless how you choose it. Okay, but then I end up with girl, girl, boy, girl, boy, girl, girl. right? Now, so basically you need to decide how many ways can you place these 3 blues on this 8 here, okay? So using this question number 54, you basically see that the question, this question here, give us exactly the same answer if I ask you instead, a quiz have 8 questions. How many ways you can get 3 wrongs, right? Okay. Now, I'm not saying boys are wrongs. No, 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 no. I'm just saying the illustration is similar to this problem. Okay. Or I have eight students, 3 of them get A's. Then how many ways, how many different combinations can these 8 people, 8 students get A's? I know the rest are B's. Okay. Now, number 62. We get into probability right now. Number 62, there are 55 Democrats and 45 Republicans in US Senate. I think it's actually the other way around right now. In US Senate right now, it should be 54-46 as I remember. Well, anyway, doesn't matter. Now suppose 55 Democrats and 45 Republicans. Let's see, so we have a box consists of 45 Democrats and 45 Republicans. Okay, now and then we will select 7. Let's see, how many ways can we select 7 people from this 100 people? The number of selection will be 100, choose 7, right? There are 100 combinations, 7 ways to select 7 people from this 100. Okay, we computed exactly the same number earlier, and we get that 16 billion something. So if we randomly select 7 people from this 100, there will be 16 billion something ways to make it happen. Now, let's see part A. What is the probability that the committee is composed of all Democrats? So probability of these 7 people, all Democrats. Then the bottom will be 100 combination 7, right? Okay, that's the number of ways to get 7 people. Now, to get 7 Democrats, all 7 Democrats, it means, all 7 Democrats, it means, how many Democrats we should get? If all of them Democrat, then there will be 7 Democrats, right? How many Republicans? If 7 Democrats, how many Republicans? 0, that's right. Okay, now then, how many ways can you select 7 Democrats from 55? There'll be 55 combination 7 times 45 combination 0. Now, when I say probability notation, this is the probability notation. Okay, this is the combinatoric notation. And then from there, you use your calculator. Okay, from there, you use your calculator. Now, everything choose 0 is 1. Everything choose 0 is 1. So this is 16, 0, 0, 7, 5, 6, 0, 8, 0, 0. Now 55 choose 7 will be be 202927725. Okay, so this guy is this guy is this. So the final answer will be divided by 127. This will be 0.012677. 5 decimal places make it 8 here. So if you have this configuration, 55 Democrats and 45 Republicans, yes, we have more Democrats in this case, but what is the probability that all 7 of them are Democrats? The probability is so small. Notice that this is less than 5%. So this is quite unusual. In fact, this is nearly very unusual. Okay, so it's more likely the selection was not done randomly. It's more likely the selection done with not equally likely event. Okay. Now, how about part B? How about part B? Can you try part B? Just give me the probability notation. I can do probability notation. Probability that when you select 7 people, all of them Republicans. But what is the combinatorics notation? The combinatorics notation will be, I see some notes from somebody here. Okay, good job, Lydia. That will be 55 from the Democrats, 55 Democrats choose nothing, 45 Republicans choose 7, over 100 choose 7. Okay, now you will actually see the following phenomena, that the sum here will be the same, and the sum here will be the same. Okay, and then of course from there you go on with your calculator work. Okay, now how about part C? Can you try part C? Probability, you still select 7 people. Probability of getting 3 Democrats, which implies, of course, 4 Republicans. Now notice that saying the committee consists of 3 Democrats and 4 Republicans is the same to just say 3 Democrats. Because when we say probability of getting 3 Democrats, it means the rest not Democrats. That's the same to say probability of 4 Republicans, because if they tell me 4 Republicans, then for sure the other 3 has to be not Republican, which is Democrat. Okay, so what they tell us here is actually redundant. They can just tell us 3 Democrats or 4 Republicans. They don't need to tell us both. Okay, yeah. So yes, you are right. Whoever that person is, who's that? Robert, that's right. That's 55 combination 3 times 45 combination 4 over 100 combination 7. Okay, now of course from there you use your calculator. Okay, now I would like to go on further before answering more problems. I want to teach you something to do the basic of what we call quality control. The basic of quality control. So you see, uh, these combination issues here starts from like A, B, C, D, E, remember, right? And then becomes chords, becomes handshaking, becomes teams, like 5 teams playing, now becomes the what, random sampling, leadership, right? Uh, Different order of genders of your children, and now gets into politics, Republican, Democrats. Okay, in one of my old tests, I actually have question about this. Just to mention it for you, there are 10 city council members, and 6 of them pro development, 4 of them pro environment. And then I want to construct, let's say, a mall in this city. Okay, now how likely I actually win the vote? Now, for that city to happen, we need to get rid of one park. You know, how likely will that happen? Right? Now, notice that I know some of you don't like me to talk into politics. Okay, no, I'm not trying to, and I'm trying to tell you how in politics people have their agenda. Okay, so be aware with how people label each other. Okay, now here I try to label these people in a positive ways: pro-development and pro-environment. Now these two labeling not supposed to be opposites though. In other words, I believe those people who are pro-development, they are for development for the city, they must be also believe in environment. Likewise, those people who wants to maintain the environment to be as natural as possible, they must be also people who want to develop the city, right? But it's more into their priority. So those who are pro-development doesn't mean they are anti-environment. They are not against each other. They are not, at least we are not supposed to see it that way, okay? But when it comes to politics, because people who has agenda, then people from this side may label people on the opposite side as anti-development. And of course, people from this pro-environment may label the other side as anti-environment. Okay, so one thing we need to see in politics is that people use labeling to give a negative or maybe positive impression about who they talk about. So one way you can say bad things about pro-development people, if you want to depict them into negative ways, you call them different name, call them anti-environment. And once we hear anti-environment, we feel not comfortable with that until you see about, okay, this city has been stagnant for many ways, for many years, for example, right? And then the tax income that we get from, for example, tax property is not enough to actually repair a lot of streets and increase, for example, the some infrastructures, the electricity, or maybe the flood control in that city, so on and so forth, right? Okay, so then somebody come in and, you know what, I need to build something. We want to build this. I want to build a mall, a small mall maybe, but then we get some people can open a mom and pop stores, okay, small stores, and that way we can get more tax beside property tax. A park, for example, will not generate money. Okay, what we need right now is money, for example. Okay, and for that we need to, sadly, we need to sacrifice this part. Then you bring it to this city council. Okay, now then, if you have this kind of configuration in that city council, what is the probability your proposal to build a mall is approved? Then that will be, let's say of these 10 people, only 3 here and 3 here will vote. So it will be 6 choose 3 times 4 choose 3 over 10 choose 6, like that.
Is it 6 because of the is it 10 choose 6 because of the voters?
Yeah, the number of ways you can select the number of ways you can select 6 people from this 10 city council.
Okay.
Yeah. Okay. And the number of ways you can select 3 from here, the number of ways you can select 3 from here. Right? That will give us the probability of that being approved. Okay. So this will be the number of ways, we can get 3 pro-development and 3 pro-environment and so on. Well, I don't think what I did here is correct. Though. I don't think what I did here is correct. But we can bring it there. We can bring it there. The main purpose of this is that I show you that it has something to do with our counting methods, the combinations that we have earlier. But implicitly, I also want you to realize that people label each other according to their agenda. Okay, so be very careful with people labeling. Okay, one thing I don't like about our politics, when I get your feedback from your quiz here, some students say that they don't like to talk about politics. I don't like that too. Trust me, I don't like that too. But it's not really about the politics, to be honest with you, from my view. It's about how they argue their case. They actually settle into labeling. And of course, that's kind of like hurt when somebody say one kind of sentence for how other people label me may be hurtful. Okay, and that's what we don't like in our political conversation. I mean, we don't really talk about the issue, right? We end up talking about something else. Well, anyway, just make you aware with that. Now, I want to talk about some quality control. This is a basic quality control issue. This is very, very basic though. Okay, now suppose I have this situation. Imagine Thomas as a not distributor, has a small phone company. Of course, this refers to cell phone company. Okay, so I sell cell phones, let's say T-Mobile, Metro PCS, right? Okay, or whatever. And then I have 100 phones at hand. Actually, instead of to sell, I buy from a distributor, from manufacturer. So I start from a manufacturer. Okay, they will send 100 phones to my store. Okay, my first question to you. When I get this 100 phones, will I check one by one? All of them, if they are working well? The answer is no, I will not. Okay, because checking 100 phones will take not only a lot of manpower, it takes a long time. Let's say one phone takes you 15 minutes to check if it's actually working well or not. Okay, and multiply that by 100 phones, then it will take 1500 minutes already. Divided by 60, that's 25 hours. And 25 hours multiplied by $15 per hour employee wage, that will be 225, 300, 3,000 something. No, this is hundreds. That's a lot of money. $375. And I may not make that much profit. That's the thing. And 15 minutes is actually a small number, right? 15 minutes each is a small number. It may be a lot more. So instead of checking all 100, I may randomly select, let's say, 3 phones to check. So 100 incoming phones. I will randomly select 3 to check. And we will reject the whole batch, reject all 100 phones if any one, or if you find any defect. Okay, let's say that's the scenario. So I will buy 100 phones from the manufacturer. I will check 3. And I will reject all batch, all 100 phones if any one of these 3 are defective. Okay, now, then the manufacturer happens to be somebody's really good in statistics. Okay, let's call that Thomas Teacher. Okay, and he knows of these 100 phones, 2 of them actually defect, 98 good. Now, then the question is, what is the probability? The first question, what is the probability that no defect selected? In other words, the whole batch will be accepted. Do you see the storyline? So I have 100 phones, 2 of them defect, 98 of them good. Okay, now we will accept, and we will select 3, right? We will select 3. And it will be accepted if, all 3 from here, nothing from here. Now, what is the probability it will get accepted? It will be 2 choose 0 times 98 choose 3 over 100 choose 3. That's the probability. Okay, that's the probability. You can just use your calculator to compute this. I use my calculator. $98 choose 3 That is 152,096 over 100 choose 3. That's 161,700. So 152,096 divided by that answer is 0.94061. It's 94%, approximately 94% probability that the whole batch will get accepted. Now, what is the probability that it will get rejected? That's 1 minus that, right? 1 minus that, that will be 1 minus 0.94061. That's if they find at least one defect. Okay, so that will be 0.05939, which is slightly more than 5%. Okay, so if the manufacturer was a bit evil, I say just a bit because most people will do this though. Okay, if they're evil, they will just send you these 100 phones, and in these 100 phones, they may include 2 phones they know to be defective. Okay, by doing so, they actually pass the loss that's supposed to be belong to them to me, because these 2 defects I cannot sell it though, unless I sell it as a big batch, right? Like what the manufacturer doing. Now you may say, "Oh, Thomas, that's illegal. How can you sell defective stuff?" Well, it depends on how you apply that rule, because of course it is illegal if the manufacturer knows that it's defective, but all the manufacturer needs to say is they didn't know, and suddenly you cannot execute them. Right? Don't you think it's strange? Huh? Okay. Yeah. I'm teaching you this not to teach you to cheat. I'm teaching you this to show you that how people actually use quality control. Okay, so from Thomas' point of view, then why do I check 3? Because if I check 3, it's enough to catch. It will be quite quite useful for me to catch the manufacturer cheating me if he sneaks in 2 defective items among this 100 by just checking 3 of them. You will see it's actually barely enough though. It's barely more than 5%. Okay, but the thing is, like, if I need to check all 100 phones, it takes me a lot more time and it will cut into my profit. Okay, I basically spend the money on my employees first, or my staff first, even before I sell any phones. Do you realize that? Now, by the way, this is actually a good example because in reality, there's a chance that, yes, I only checked 3 of them. And you know that if you buy a new phone, it's very likely it's sealed, so there's no way for us to check it, right? Okay, how do we know it's defective or not? When Thomas sells it to his customer, I will give them, let's say, 3 months. I think it's usually just 1 month, right? In 1 month, if anything wrong, you can bring it back. I will exchange that for you. But otherwise, that's it. The sales is done. It's final, right? In other words, instead of me paying my employees to check these 100 phones, I sell it to my customer first. Okay, my customer will use it, and implicitly they do the checking, right? Once you find something wrong, you will come back to me, and then I will exchange it, right? Okay. But that way I can save my checking. I can save my money in paying for my employees to check this phone. Okay, so remember I told you a couple of days ago, or maybe even yesterday, that I want you to be rich, right? Okay, I'm not trying to teach you how to be rich by cheating. No, I'm teaching you how to be efficient. You know that however you check these 100 phones, your buyer, your customer will check it anymore anyway. And you have to give them warranty anyway. And that warranty actually coming from manufacturer. So what's the point of checking them? Right? Just sell them first. Okay? If something wrong with the phone, they will come back in 1 month. I mean, they pay a lot of money for that. If they don't come back, that's stupid. Right? Sorry if I use that word stupid, but yeah, if you spend $1,000 on your iPhone and something wrong with that, you don't complain on Facebook. Okay? The first thing you do is you go back to the store. Does it make sense? Right? Okay? And that's how the manufacturer actually save money by quote unquote making you do what their employee is supposed to do. Actually, that's what you're supposed to do as a customer too. Okay, don't get me wrong. You don't buy something and not checking it at all, right? Okay, you don't buy your phone and then leave there for half a year not using it. No, you use it right away, especially for something you pay so much for. Okay, well, anyway, so you see, this is the probability of the defect and no defects selected, and therefore we get the question, what's the probability that it gets rejected? Okay, now with this computation, then if the manufacturer knows the way, so the fact that I will check 3 phones of 100 batch is supposed to be a company secret. Because if the manufacturer knows that I check only 3, then they may reduce this 2 defect down to only 1. And the chance for me to catch it will be a lot less. Okay, now, but if I check 5, for example, I think having 1 is still above 5%. So the internal company in the internal will not reveal how many you check. Okay, because that will implicitly tell the manufacturers what kind of scheme, what kind of probability for me to catch you cheating me. Okay, again, this is quality control. So this quality control is not about only the math behind it, but implicitly tell us that this checking 3 in this case is actually part of the company secret, and it's supposed to be part of the quality control. That's why a company will only tell you they do quality control, but they will not tell you how they do their quality control. Okay, they may provide that to their customers on how they deliver the product, okay, but it will not tell the supplier how they check incoming material that they use to sell further. Okay, number 66, packaging error in 1 minute. So we have 3 cans marked regular soda filled with diet soda and put into 12 packs. So in this 12 pack, 3 of them supposed to be diet. Yeah, so 3 of them diet. The rest 9 actually the regular soda. Okay, so this was this 3 is the one incorrectly marked. Okay, determine the probability that exactly 2 diet soda. Probability that 2 diet. It means you need to select 2 from here. How many cans do we select? Oh, we select 3. Huh? Yeah, we select 3. So if 2 from here, there must be 1 from here. There will be 3, choose 2 times 9, choose 1, over 12, choose 3. That's the probability combinatorics notation. That will be 3 times 9 over 12, 2, 22, 220. So that would be 27 over 220. Okay, now with this said, let me ask you to do suggested homework from our textbook. I would like you to do, start from number, I'm sorry, I'm a bit over time. Start from number 45 to number 67. So 5.5, 45 to 67. How about 5.6? Now 5.6 basically all those 5.5 put together. Okay, so you may get, actually 5.6 will be the what's that? The summary of pretty much all of them. Basically, I would like you to do up to number maybe 31. From number 1 to number, is it from number 1? Let's see. From number 5. From number 5 to number 31. That's your suggested homework. Okay, just do the odd ones. Okay, now tomorrow we will go on with the new chapter, chapter 6. Okay, so try to do this suggested homework and start looking into the quiz one. The quiz, you can do question number